In this segment, we will talk about quadratic interpolation. And again, we are doing this quadratic interpolation by using the direct method. So in quadratic interpolation, what you're going to do is you're going to choose 3 of the data points which are given to you. Keep in mind again that you might be given several data points, hundreds or millions, but for quadratic interpolation, you're going to choose the 3 data points which are of use to you. And then let's suppose this is x naught, y naught, this is x1, y1, this is x2, y2. So you're going to simply draw a second order polynomial which goes through those data points. So this will be a second order polynomial. And it will be the form a0 plus a1x plus a2x squared. And the question arises, how do I find a0, a1, and a2? That's simply by substituting the values of y at these values of x. And you'll be able to set up 3 equations, 3 unknowns. And then you should be able to find the value of y at any value of x which might be of interest to you. So let's go and look at this particular problem through an example. So let's suppose the upward velocity of a rocket is given at these particular times. That the value at time t equals 0 is 0, at 10 is 227.04, at 15 is 362.78, at 20 it is 517.35, at 22.5 it is 602.97, at 30 it is 901.67. So let's suppose we are given the value of the velocity at these 6 different data points and we want to do quadratic interpolation. So the first question arises that I have to find out which points I should choose for the value of the velocity to be calculated 16. So what I need to do is I need to see that which are the 3 closest points to 16, but I also need to make sure that the 3 points which I would choose closest to 16 should also bracket the number 16. So let's suppose if I choose 15, that's 1 away, 20, that's 4 away, and those bracket the closest. Then should I choose 22.5 or should I choose 10? 10 is 6 away from 16, while 22.5 is 6.5 away from 16, so I should be choosing 10. So you made the decision about the 3 data points based on what is the distance between these data points and 16, but at the same time also make sure that the 3 data points you're going to choose for the quadratic interpolation also bracket this point of 16. Otherwise, it will be extrapolation. So let's go and see that what I'm going to do is I'm going to choose the velocity expression to be a0 plus a1t plus a2t squared. That's what I'm going to choose. And now what I need to do is I need to substitute the values of velocity at 10, 15, and 20 to set up my 3 equations, 3 unknowns. So I'll have 227.04 will be the value of the velocity at 10, 362.78 is the value of the velocity at 15, and 517.35 is the value of the velocity at 20. So what this is going to do is going to give us 3 equations, 3 unknowns. So you can set them up in the matrix form. So if I set them up in the matrix form, I have 3 unknowns, a0, a1, a2. And the coefficient matrix will be 1, 10, 100, 1, 15, 225, 1, 20, 400. And the right hand sides will be the velocity numbers which I have, 227.04, 362.78, and 517.35. So I get 3 equations, 3 unknowns. And what I need to do now is to take those 3 equations, 3 unknowns, and solve them by using any of the methods which I have learned in my simultaneous linear equations, whether it's Gauss elimination, Gauss-Seidel method. So what I'll do is what I find out is these are the constants I get. A naught I get to be 12.05. A1 I get 17.733. A2, I get 0.3766. So what that means is that the velocity expression which I have is A naught plus A1 times T plus A2 times T square. And again, it's important to say that this is the interpolant and in what domain this particular interpolant is valid. And the domain in which this interpolant is valid, it is between time t10 and 20. So now I want to find the velocity at 16. It turns out to be 12.05 times 17.733 times 16 plus 0.3766 times 16 square. And this value here turns out to be 392.19 meter per second. And that's the value of the velocity which you're getting at 20. Now the question arises that we are doing quadratic interpolation. How do we know that how much we can trust this solution? Or which significant digits can I trust in the solution? So in order to be able to do this, what you're going to do is you're going to look at what did you get for the value of the velocity at 16 when you were doing linear interpolation. When you did linear interpolation, you got 393.70 meters per second. This was from linear interpolation. And the value of the velocity at 16 is 392.19, which we just got by using quadratic interpolation. So what we can do is we can look at this as our previous value, and we can look at this as our current value. So this is the previous value which we obtained by using linear interpolation, and this is the value which we obtain now by using quadratic interpolation. So I'm going to calculate my absolute relative approximate error by current approximation, which is from the quadratic interpolant, minus the previous approximation, which is from the linear interpolant, and then multiplied by 100. And in this case, which I get is 0.384%, which basically tells me that I can trust two significant digits in my answer, because less than equal to 5% would be one significant digit, less than equal to 0.5 would be two significant digits. And in that case, what that means, I can trust this 3 and I can trust this 9, because this is less than or equal to 0.5%, which represents two significant digits to be at least correct in my solution. And that's the end of this segment.